Upam as zero crossing detector. It is a very interesting question how operational amplifier acts as a zero crossing detector. Also you will have question discuss how operational amplifier acts as a voltage comparator, or also you will get question like this: what is voltage comparator, and explain the operation of voltage comparator. So before going to know about zero crossing detector, you must have idea about voltage comparator. So what is a voltage comparator? Voltage comparator is also called as simply comparator. A voltage comparator or simply a comparator is a device that compares an input voltage with a reference voltage. So you are given in the experiment, you will give, it will be given to you two voltages. One is your reference voltage, sometimes it is called VR, reference voltage, and another voltage is called your the input voltage. And you have to compare the input voltage with the reference voltage, and the reference voltage is basically a DC voltage, and your input voltage is a AC voltage. So how an operational amplifier can be used as a comparator? This is the operational amplifier. I have explained about the operational amplifier in the previous video. So you watch my previous video before watching this video. So this is the inverting end of the operational amplifier, the negative end, and this is the non-inverting end of the operational amplifier. And here V plus, this is the supply voltage, and V minus, this is also the supply voltage. So V plus and V minus, these are the supply voltages, and VO, this is your output voltage. So you have VR, that is the reference voltage, which is you can take a DC voltage, and VI is the input voltage or the voltage which you compare, and VO, this is your output voltage. And the two voltages, one is your reference voltage, another one is your input voltage. The two voltages to be compared are applied to the inverting and non-inverting inputs. You have to apply the two voltages at the inverting and non-inverting inputs. I have told you about the inverting and non-inverting inputs. And this is the mechanism. I will explain the mechanism how the operational amplifier compares two voltages. Suppose this is your given AC voltage, and you have a DC voltage. Suppose the reference DC voltage is at the inverting input is equal to VR. I have written here VR, which is the reference DC voltage at the inverting input, that is the minus input, and this is also called VDC. VR for reference voltage, this is also equal to, I have written here, equal to VDC. And the maximum value, this is your AC voltage, and the AC voltage is at the, suppose, non-inverting input VI. This is your AC voltage at the non-inverting input or plus input, and suppose VI is written as Vm sine omega t. What is Vm sine omega t? The Vm is your maximum value of voltage. Here I have taken Vm, that is the maximum value of voltage or peak voltage, and I have represented the input voltage in a sine wave. Okay, and suppose this is the graph between time and input voltage. I have taken time along x-axis and input voltage along y-axis, and in the input voltage you have the DC voltage or RMS voltage or reference voltage. This is your reference voltage, this point is your DC voltage, and this point is your peak voltage, and you can see the peak voltage here. And the output voltage, this is the graph for the output voltage. So the output voltage V output, it is in between plus V and minus V. Maximum value of output voltage is V. So in comparator, the output voltage switches to plus V. You see the output voltage will be plus V, this amount, when the input voltage is greater than the DC voltage. You see, from here to here, from this point to this point, the input voltage is greater than Vm. Okay, and in this case, the output voltage will be equal to V plus this value. And when the output voltage will be equal to V minus, you see, when the output voltage will be equal to V minus, output voltage switches to V minus when the input voltage is less than Vr. You see, from here to here, the output voltage is the input voltage is less than Vr. In this case, the output voltage will be equal to minus V. Okay. So in this way you can get the output voltage, and the output voltage will be repeated. So for a given input voltage you will have the output voltage, and you can compare one voltage with the other voltage. So you should write the mechanism like this as I have discussed. Let the reference DC voltage at the inverting input Vr and AC voltage at the non-inverting input Vi, which is equal to Vm sin omega t. Vm is the maximum value of peak voltage or peak value. The output voltage is V output, and from the graph it is clear that in comparator the output voltage switches to plus V when input voltage Vi greater than Vr or VDC, and the output voltage switches to minus V when the input voltage Vi is less than Vr. And this is the mechanism in comparator. And the next question is, what is zero crossing detector? When a comparator is called zero crossing detector. A comparator is called a zero crossing detector if the inverting or the non-inverting terminal is grounded. If the inverting terminal or the non-inverting terminal will be grounded, either or, then the comparator is called zero crossing detector. So we will discuss what will happen when the inverting input is grounded. So when the inverting input will be grounded, you will have non-inverting input and non-inverting output. Suppose the non-inverting input is Vi and non-inverting output is Vo. So when the non-inverting input is slightly positive, then your output voltage, non-inverting output voltage will be equal to plus V. And when the non-inverting input is slightly negative, then output voltage will be equal to negative. You have to remember this. In zero crossing detector, you will have two cases. Either the inverting end will be grounded or non-inverting end will be grounded. When the inverting input will be when the inverting input is grounded, then you have non-inverting input, and for non-inverting input, suppose Vi, if it is slightly positive, output voltage will be positive. If it is slightly negative, then the output voltage will be negative. And when the non-inverting input is grounded, in the other case, first we have discussed the inverting input is grounded. Now when the non-inverting input is grounded, non-inverting means the positive of the operational amplifier. When the positive end of the operational amplifier will be grounded, that is the non-inverting input is grounded, you will have input voltage and output voltage. In this case, the inverting input voltage and you have inverting output voltage. If the inverting input voltage will be slightly positive, then the output voltage will be negative. You see, just opposite to the inverting input when it is grounded. Okay. But when the inverting input is slightly negative, then the output voltage will be positive. In this case, it will be negative, then it is negative. In this case, it will be negative and it will be positive. You see, the input in both the cases are same. When input is positive, output is positive. When input is negative, output is negative. In case when the inverting input is grounded. But when the non-inverting input is grounded, when the input is positive, output is negative, just opposite. And when the input is negative, output will be positive, just opposite to this. So you have to remember this thing in zero crossing detector. You will have short question also in zero crossing detector. These questions will be multiple choice question or short question. So these are the probable long questions. Discuss how operational amplifier acts as a voltage comparator, or you may ask to what is a or write a short note on zero crossing detector, or what is a voltage comparator, and explain the operation of voltage comparator.